methodology of econometrics. So according to the classical methodology, this is the classical methodology, classical economists who derived this methodology for the econometric modeling. So as I told you, the first stage or the first step is the statement of theory. So statement of theory, this entire process of methodology has been explained using the using a theory of J.M. Keynes, which we have earlier studied in our economic thought also. So the fundamental psychological law of consumption, which was given by Keynes, which states that the relationship between income and consumption. So as the income increases, the theory states, as the income increases, consumption also increases, but not as much as the increase in the income. This is what the psychological law of Keynes states. So here, in order to explain this theory, we have taken the changes in the aggregate income of the economy and expenditure of on consumption by the household. So these two variables, economic variables, are being taken, and the relationship is being studied to look into whether what is stated by the Keynes is also applicable here. So this relationship here is this relationship between the income and consumption is explained through the marginal propensity to consume. So what is this marginal propensity to consume? So with an increase of 1 rupee income, what is the income, what is the change in the consumption expenditure? So is the consumption expenditure increasing by 50 paisa, or is it increasing by 60 paisa, or 70, or 80, or 100%? Okay, so with 1 rupee change in income, what is the change in the consumption expenditure is quantitatively expressed by the marginal propensity to consume. So it is this marginal propensity to consume explains the change in the consumption expenditure due to the change in the income. Okay, and this MPC is always greater than 0. It has to be greater than 0, but it is greater than 0, but it can never be it has to be less than 1. So it is like the symbol where you have the greater, it can be greater than equal to 0 and but less than equal to 1. So that is the value of the marginal propensity to consume. So what does this signifies? That either the consumption expenditure is equal to 0, that is, even when there is an increase in the income, the consumption expenditure is not changing, it is remaining as 0. That is what it is signifying. Okay, but it has to be less than 1, but which means to say that whatever change in the consumption expenditure is happening is due to the change in the income. That also is being explained by this marginal propensity to consume. So it only explains the change in the consumption expenditure that is happening due to the change in the income. It is very, very clear in explaining this. So quantitatively it expresses that. So it does not, it's not concerned with the assets and the lottery gains, all that are put as constant. Okay, so that you have to understand. So that is what this MPC states. It is greater than equal to 0 but less than equal to 1. Okay, the next step here is, now this particular theory we are transforming it into a mathematical model. So the mathematical model is y is equal to beta 1 plus beta 2 x. Okay, where y here is the consumption expenditure. So in our example here, I have taken the data from the RBI website and I have taken per capita private final consumption expenditure. This is being taken, and to measure the income I have taken per capita GDP at market price. So these two data has been collected to test and see whether this relationship is existing empirically. Okay, so this beta 1 and beta 2 are the parameters, and this beta 1 is nothing but the intercept coefficient and beta 2 is the slope coefficient. Okay, so if the model has has only one equation. Okay, one equation here we are expressing where we have one dependent and one independent variable. Either it is called as a single regression model. It is a single regression model, and there are two variables, one dependent and one independent variable. Such model is called as a single regression model or two variable regression model. Two variable means one dependent and one independent. So dependent variable here is consumption expenditure and independent variable is the income. Okay, so this is the mathematical form. Now once the mathematical form is determined, after that we have to transform it into a econometric model or a statistical model here. So this mathematical model, always mathematical equations, they explain exact deterministic relationship. That is, either whatever, if it is a positive means exactly it will determine this much, this is the change in the consumption due to the change in the income, because it's all numbers. It's just only numbers. So maths takes the numbers, determines the relationship by solving the equation. It does not concern about the other factors. But in economics, we cannot leave away the other factors, because other factors do have a very important role, and not always we will be able to predict its nature. So that is why we have to transform that mathematical model into an econometric model. So for example, if we collect the data on consumption expenditure and disposable income, that is after the tax of 100 households in Chennai, and plot a graph, okay, what we cannot expect that all the people who is having an income of supposing 100 rupees per day, they are all spending only 80 rupees. Or they are all spending only 60 rupees. It is not possible, because some who is earning this income of 100 rupees may want to save 50% of it, and he may only spend 50 rupees. But some may want to spend 90 rupees. Some may want to spend only 40 rupees. Some households may want to spend 60 rupees or 70 rupees. So it's that exactly they are all of them spending only 50 rupees or only 60 rupees is not possible. So that's what the mathematical model states. Because why this difference is there, why one household is spending only 50 rupees, the other is spending 80 rupees or other is spending 70 rupees, is because of the various factors. Because the household size may be less. Some households may have more family members, some may have less family members, some may have more expenditures in terms of medical or in terms of food. They may spend more, but it is not the case of all the households. So because of the influence of the other factors, there may be a change in this relationship. So that is why we have to transform. So that is why we incorporate a term called as U. The disturbance term or error term, residual term, these are all different names. Random term or stochastic disturbance term, that is which is commonly called. So the above econometric model here, this model y is equal to beta 1 plus beta 2x plus x is a linear regression model. So regression model, econometric model, where you have brought in that random factor also in the equation. So this model is basically the econometric model which we have transformed from the mathematical model. Okay, then once we frame the model, we go in for the obtaining the data. As I told you, I have taken the aggregate per capita private final consumption expenditure and per capita GDP as measured from in this particular period. So when we plot, this is how the data is being plotted. You can see on the x-axis you have the per capita GDP, which is your independent variable, and on the y-axis we have the dependent variable, the private final consumption expenditure. So this is how. So when the GDP is increasing, you can observe that the per capita final expenditure is also increasing. That's what the linear line. This is the linear regression line. Okay. So now once we determine this linear relationship, we estimate the parameters. So that is why this symbol comes, where you have y hat beta 1 hat and beta 2 hat. So what we are doing here, we are estimating, we are taking a particular time period and then we are using that time period only to measure the relationship. So all the other time periods we have not. So for 10 years we are taking the data and we are estimating. So only for that period, only 2011 to 21 if you are taking, in that case, that for that they take data only, using that data only we are estimating. So in that case, the equation which I showed you previously didn't have this hat symbol, but now it will have a hat symbol when we use the data and estimate. Okay, so that is what is explained here. So this beta 2 is nothing but your MPC, which explains the per unit change in the final consumption expenditure as a result of 1 unit change in the GDP. Okay. Then hypothesis testing. The hypothesis says that MPC is positive but less than 1 and it has to be greater than 0. So in our equation we got the value of 0.549. So we must inquire if this estimate is sufficiently below 1. So that there is no chance of occurrence, or due to peculiarity of the data, it's not like a probability. So we have to statistically signify it. We have to test whether statistically it is significant enough to explain that this model can be used for the future reference also. So that we will be doing in the hypothesis testing. You have various tools. We had the student t-test which we use, or the chi-square test which is being applied, and we check the significance of this particular value of the beta 2 hat which we derive. So that is being done in the hypothesis testing. Then once we test, we will forecast, so we can forecast any future data. So in 2026, whatever, if the GDP is going to be increasing by so many units, what will be the impact of that on the consumption expenditure can be done once the model is estimated. So that is what is the forecasting and prediction. Then once we determine the forecast, and once we are using it for forecasting, we can use it for the various policy framing purposes. Because if you want to determine, that the consumption expenditure should be in under certain limits, then what has to be the change in the GDP, and how we can control the GDP, or what other factors can be controlled to ensure that the consumption expenditure does not increase by so many points or so many units. Okay, so that is what is using the model for the control or policy purpose. So this is your methodology. Okay, thank you.